Welcome back, stargazers. In our last journey through the universe, we delved into the wonders of Messier objects 45 through 55, exploring everything from the famous Pleiades cluster to the stunning Whirlpool Galaxy. If you missed that episode, be sure to check it out and join us as we continue our cosmic adventure. Today, we're picking up right where we left off. From the densely packed globular clusters to the grand spiral galaxies, we're diving into Messier objects 56 through 66. Get ready to uncover more secrets of our amazing universe. But before we begin, if you are new here, don't forget to give a thumbs up and subscribe to the channel. Our first stop is Messier 56, a globular cluster in the constellation Lyra, located about 32,900 light-years from Earth. M56 is relatively faint, with a loosely concentrated core. It contains several 100,000 stars, many of which are very old and have a lower metallicity compared to younger stars. Through a telescope, you can resolve its individual stars, making it a beautiful and rewarding object to observe, especially in darker skies. Next, we move on to Messier 57, also known as the Ring Nebula, in the constellation Lyra, approximately 2,300 light-years away. M57 is one of the most famous planetary nebulae, known for its distinct ring-like appearance. The nebula is about 1 light-year in diameter and was formed by a shell of ionized gas ejected from a red giant star in the later stages of its evolution. The central white dwarf can be seen with larger telescopes, adding to the intrigue of this celestial object. Continuing our journey, we find Messier 58, a barred spiral galaxy in the constellation Virgo, roughly 68 million light-years away. M58 is one of the brightest galaxies in the Virgo cluster. It features a prominent bar structure and well-defined spiral arms. The galaxy spans about 120,000 light-years in diameter and has an active nucleus which may harbor a supermassive black hole. It's an excellent target for those interested in galaxy morphology and dynamics. Our next destination is Messier 59, an elliptical galaxy in Virgo, approximately 60 million light-years away. M59 has a relatively elongated shape and is populated by a large number of old stars, giving it a smooth, featureless appearance. It spans about 90,000 light-years and contains several thousand globular clusters. The lack of new star formation makes it an interesting object to study for those curious about the evolution of galaxies. Shifting our gaze, we encounter Messier 60, another giant elliptical galaxy in Virgo, about 55 million light-years from Earth. M60 is notable for its bright core and massive size, surrounded by numerous globular clusters. It spans about 120,000 light-years and contains a supermassive black hole at its center, which is estimated to be about 4.5 billion times the mass of the Sun. M60 has been the site of several supernovae, making it an exciting object for both professional and amateur astronomers. Next, we visit Messier 61, a barred spiral galaxy also in Virgo, approximately 52 million light-years away. M61 is a face-on galaxy with well-defined spiral arms and active star-forming regions. Spanning about 100,000 light-years, it is one of the largest members of the Virgo cluster. M61 has a bright nucleus with several H-Roman II regions, indicating areas of intense star formation. This galaxy is a stunning sight for those with larger telescopes. Continuing our exploration, we come upon Messier 62, a globular cluster in the constellation Ophiuchus, roughly 22,200 light-years away. M62 is a dense cluster known for its irregular shape and high concentration of stars towards its center. It contains about 1 million stars and spans approximately 85 light-years. Its tightly packed core makes it a fascinating object for stargazers, especially with moderate to large telescopes. Next, we arrive at Messier 63, also known as the Sunflower Galaxy, in the constellation Canes Venatici, about 29 million light-years away. M63 is a spiral galaxy with a bright core and numerous star-forming regions. It spans about 98,000 light-years and has tightly wound spiral arms that give it a sunflower-like appearance. M63 is an excellent example of a flocculent spiral galaxy, with patchy, discontinuous arms that are rich in young, blue stars. Our journey now takes us to Messier 64, famously known as the Black Eye Galaxy, in the constellation Coma Berenices, approximately 17 million light-years away. M64 is distinguished by a prominent dark dust lane in front of its bright nucleus. This unique feature gives the galaxy its nickname and suggests a past interaction or merger with another galaxy. M64 spans about 54,000 light-years and contains a counter-rotating disk of gas, making it an intriguing object for study. Next, we visit Messier 65, a spiral galaxy in the constellation Leo, about 35 million light-years from Earth. M65 is part of the Leo triplet, a group of 3 interacting spiral galaxies. It spans about 100,000 light-years and has a slightly tilted appearance with a bright core and well-defined spiral arms. The galaxy shows signs of gravitational interactions, including a warped disk and disrupted spiral arms. Our final stop in this episode is Messier 66, another spiral galaxy in Leo and a member of the Leo triplet, roughly 35 million light-years away. M66 spans about 96,000 light-years and has a distorted shape, likely due to gravitational interactions with its neighboring galaxies. Its bright core and asymmetrical spiral arms make it a fascinating object to study. The tidal forces from these interactions have triggered star formation in its spiral arms, making M66 a dynamic and captivating galaxy. As we wrap up this episode of Messier Objects, how many of the 11 discussed in this video did you recognize? Let us know in the comments below. Join us in further episodes as we continue to unravel the secrets of the cosmos, one Messier object at a time. Don't forget to subscribe to the channel for more fascinating content, and give this video a thumbs up if you enjoyed it. Until next time, keep looking up and exploring the cosmos.